Hi, my name is Abigail Clark, and this is my Physics Lab 5, Build Your Own Adventure, and I chose to do the following Slinky experiment. So today in this lab, we're going to predict and analyze what happens to the base of the Slinky as it's dropped from full extension. Does it stay stationary during the fall? Does it all fall at the same time? That's what we're going to see today. So some of the main physics law that we're going to see today is Newton's second law. And the properties of the force of gravity are also taken into account. And then below I've included the equations for Newton's second law, which are the final velocity equals the initial velocity plus net force over mass times delta t. And then the final position equals the initial position plus the average velocity times delta t. And today we're going to see that the initial velocity is 0 because it's at rest, and we also made the initial position 0 as well. Okay, so this is my experiment. I'm not going to show it all, but I do want to show a bit.
Yeah.
So, you can see at the top the Slinky falling, and then here, about here. I'll let it play for a second, but it falls to the ground, and it kind of bounces around, but see, you can see. That's where the frame's glitched a little bit, but you can see it falling to the ground there. Yeah, that was the experiment. So these are my results, and as you can see, I included the graph from Tracker, and also I created my own scatter plot data just so you could see it a little bit better. But in Tracker and on, they're both identical data, but you can see that at the beginning of the experiment, the Slinky stayed in the same place, the base of it, and then as the Slinky came down and hit the base, then the base fell as well to the ground. And you can see there's a couple of gaps in my data, and that's from the frames glitching. You could see that a little bit in the video. And then also the Slinky, just like tracking in Tracker was a little bit difficult because it does happen so fast. So it does change the data just a little bit. But as you can see, like it's a very negative like a negative trend. And it happens very quickly because you could tell majority of the video it's in the same place, and then all of a sudden it just goes down over the course of about 2 seconds, which is very fast. So yeah. So I also want to talk about some possible sources of error. For me, this time Tracker was a little bit glitchy. I had some frames glitch out, like I said on the previous slide, so it caused some gaps in my data, which is unfortunate, but sometimes it happens. And also just tracking the object, like tracking in Tracker with the point mass system was a little bit difficult because the video from YouTube became a little bit blurry, and then the axis was there, so that could have also caused some slight misconceptions of the data. And then the big question for today is what happened to the Slinky as it was dropped? That's the whole reason for this experiment. What happened to the base of the Slinky? Well, as you saw in the video, and I skipped to, the Slinky as it fell, the base stayed in the same place, but the momentum of the top of the Slinky as it came down and hit the base caused the base to go down to the floor and or fluctuate a little bit as it went down to the floor, but eventually it was at the floor. And so I think that this is because of Newton's second law and the momentum principle, because the energy and momentum are going to be conserved, and when the top of the Slinky hits the base, it's kind of transferring that momentum to the bottom of the Slinky and then hitting the ground because of the way the Slinky's made, the hollow middle, and just the whole momentum there. And yeah, that's what I think happened to the Slinky, but in this experiment exactly. And yeah, thank you for watching my lab, and have a good day. It's the last one.